as previously threatened, we're going to develop two formula here to use for you to determine minimum deadband and maximum deadband settings for this particular controller. And in this controller, if you will recall, we first need to determine what our deadband is in actual foot candles, and then determine a deadband percentage setting, which is based on this cut-in value when a stage of lights first turns on. Now, we know that our cut-out value will be higher by at least 10% because that's the minimum we can set in this particular controller. And we're going to be shifting this controlled lighting up and down, if you will. Our requirement for minimum deadband depends on how much of a stage of controlled lighting hits the sensor, which is theoretically only looking outdoors. When one of these luminaires turns on, even if it's not up down like this one, lighting will bounce around, it'll reflect off the window, and the sensor will see it. Now, if we are hip, cool, and groovy, and we use the system sensor and the display on the controller to determine how much of that controlled lighting is hitting the system sensor, we need to remember that we are entering values into the controller based on what we see at our task location, reference location, location of interest. The controller will then multiply up by the sensor ratio to determine what it's looking for on its system sensor. So, if we do use the controller and its sensor to determine how much controlled lighting is landing on the sensor, we need to divide that down by our sensor ratio to determine how much the system is thinking it's seeing for that interfering lighting at the task location. So let's take a quick look at this. Remember, we're entering points on this line, the interior, the equivalent interior daylight illumination line, not the raw system sensor reading. Now we're looking at the difference here between sliding these electric lighting stages up and down, as it were, and it's based on interior foot candles. We run a test. You, as the commissioning agent, runs a test on this system and discovers that one stage is putting 2 foot candles on the system sensor. It's reporting, oh, when this one comes on, I see 2 foot candles. Another stage may be putting on 6. Another stage, it might be seeing 8. Well, we'll use something close to the sensor ratio that we found in Module 3 for acceptance testing of 2.7. If the sensor is reporting that it's seeing 8 foot candles on one of the stages, that's its highest stage that's hitting it, we divide by the sensor ratio of 2.7 and we come up with 2.96. If we round it up to 3, that's still too close. So we round it up to 4. Okay, and that would be the minimum dead band foot candles that we are programming for. Now in the last example, this one, we just stuck with a minimum deadband setting, but you may want these points to drop elsewhere, and we'll cover that in the next module for maximum deadband calculations. So we are looking for dead band foot candles minimum, in our case equaling 4, but we won't worry about that now, and we know that that is going to be the cutout value minus the cut in value. Alright? Cut out. We'll put this in brackets so we know it's one value minus cut in. Right? Because that is how much we are shifting these two sawtooths up and down. Alright? The manufacturer tells us that cut out is equal to deadband percent times the cut in plus the cut in. And we're going to substitute that for cut out, right? Because we know that that's what cut out is equal to. Dead band foot candles minimum. This is one that you determined empirically or guesstimated, right? Well, what's the rest of our formula? Minus cut in. So we substituted this for the cutout because that's, even in the manufacturer's documentation, that's what they tell us it is. Well, now we've got cut in minus cut in. Oh, guess what? Anything minus itself is 0, right? This reduces our formula to dead band foot candles minimum, our desired minimum foot candle shift, right, equals dead band percent times cut in, which we picked it for this stage and we base the other ones on what we picked. So this implies, by dividing both sides by the cut in, that the dead band foot candles minimum divided by cut in equals the dead band percentage, and this is minimum percent dead band. And this is exactly what we did when we were just noodling it out in the last module of this course. Now, if any of this algebra, and this is very simple, high school algebra, is confusing you, well, you have no reason to be setting up lighting control systems. You shouldn't be doing it. Alright? You should go and be honest with yourself and go out and get a job deep fat frying fish sticks. A second option is to go get a high school algebra book and make sure you know the grade school arithmetic required to solve the high school algebra problems. The third option is keep doing what you're doing because your customers trust you, you're getting paid a lot of money, all that stuff. Get found out, get caught out, get fired, sued, lose all your customers, and at that point it's too late to get that high school algebra book. And always remember, the fish sticks await you.